Okay, so it's 11 a.m. and I think we're going to start on time today. So, so thank you for joining us today and welcome to our December webinar on the NPD Closure Project. My name is Margot Thompson and I'm a communications specialist supporting the NPD Closure Project. Today, Katie Hogue, the manager of regulatory approvals for NPD, will be discussing the revised environmental impact statement for the NPD Closure Project, which we will be submitting to the Canadian Nuclear Safety Commission later this month. You're welcome to ask questions at any point during Katie's presentation through the Q&A button at the bottom of the Zoom screen, and we'll have the question and answer session after Katie's presentation. Juliette Louise, an environmental specialist with the project, will also be joining Katie during the Q&A session to help address any questions. Before I hand it over to Katie, I'd like to go over a few logistics for today's webinar. So first of all, this webinar is available in both French and English. You can choose your language of preference with the globe icon at the bottom of the Zoom screen on the right. As I mentioned before, the Q&A icon is also found on the bottom of the screen. And then after today's webinar, we'll be sending out a short survey to all attendees to get feedback on how you found the webinar today. And this will also be an opportunity to ask any remaining questions you may have about today's topic. As usual, we will be posting the recorded webinar to our YouTube channel in the next few days. Okay, with that, Katie, I'll turn it over to you.
Good morning, everyone. I'd like to welcome you to the final webinar of 2020. As Margot mentioned, I'm the manager of regulatory approvals for the MPD Closure Project. And we also have on our webinar today, Juliette Louise, an environmental specialist for MPD, and we'll both be available to answer questions at the end of this presentation. Today, I'd like to share what we've heard from the public, Indigenous groups, and federal and provincial authorities, and what changes we've made to our environmental impact statement since we originally submitted the draft back in 2017. First, I'll just take a few moments to provide the history of MPD, its current status, and explain the environmental assessment process. Before we jump into the topic of the day, I'd like to remind you of some of the topics we've discussed at our webinars since we started them back in 2018. At that point, we provided an overview of our 2017 draft environmental impact statement, or EIS, and now we're ready to tell you about our 2020 revised draft EIS. Through our webinar series, we've touched on a range of topics, including alternative options, engineering challenges of in situ disposal, our waste inventory, safety barriers for the MPD waste facility, and details of our follow-up monitoring program. Today, as I've already mentioned, our focus will be on the revised draft EIS and the changes and improvements that we've made. General flow for today's webinar, we'll start with what is the NPD Closure Project? What is an environmental assessment? What have we heard? What have we changed? What goes into the MPD Closure Project environmental impact statement? What does the package consist of? And then what's next for the project? So starting off, what is NPD? The NPD reactor was a 22 megawatt electric pressurized heavy water reactor that served as a demonstration reactor for CANDU technology. The MPD reactor was the first reactor in Canada to deliver power to the electrical grid. It paved the way for Canada's current power reactors such as Bruce, Pickering, and Darlington, and served as a training center for operators in Ontario and around the world. The photos on this slide show a view of the control room at NPD. So the NPD reactor operated from 1962 until 1987, at which point it was shut down and phase 1 of decommissioning was completed. These initial decommissioning activities included defueling and draining the reactor, transferring nuclear fuel and heavy water to the Chalk River site, and shutdown and removal of systems, structures, and components that were no longer required to keep the facility in a safe state. Since then, the reactor facility has been in a storage with surveillance phase for more than 30 years. This phase is also considered part of decommissioning, and it allows radiation fields to naturally reduce. This brings us to where we are today, and now it's time to finish the job and complete the decommissioning, which will mean we're not leaving the liability for the next generation. So now we'll move on to what is the MPD Closure Project. Right now, this is a proposal. We're proposing to complete the decommissioning of MPD using the in situ disposal approach. Completing the decommissioning of MPD is part of a Government of Canada priority to protect the environment and its obligation to responsibly address its radioactive wastes. Essentially, the activity of in situ disposal, we will use the existing structure consisting of thick reinforced concrete walls that stretch down almost 10 meters below grade and into bedrock as the disposal facility. Grout will be used to envelop the activated reactor components and other contaminated systems to reduce the risk of subsidence over time. This can be seen in the image at the bottom of this slide. The above grade structure will also be demolished, and this material will be placed in the empty spaces below grade and also grouted. The grout monolith will be partly overlain by a reinforced concrete cap and entirely covered with an engineered barrier. The concrete cap will be installed to prevent inadvertent human intrusion into the area where the long-lived radionuclide material reside, and the engineered barrier is designed to prevent rain and meltwater from percolating into the grouted monolith from above. What will remain at the end of the decommissioning is a low grassy hill covering the buried waste disposal facility. This small area will continue to be fenced to restrict access to the facility and to define the footprint of the licensed area. The ventilation stack will remain in place as critical habitat for the chimney switch, which is one of our local species at risk. The final condition of MPD can be seen in the image on the right-hand side of the screen. After our active decommissioning work, the site will enter a period of institutional control, lasting at least 100 years, when regular follow-up monitoring will be undertaken to ensure that the disposal facility is performing as expected and that people and the environment remain protected. So we've covered off what is MPD and what is our proposed project, but now I'll briefly explain the environmental assessment process. The detailed expectations for our assessment are outlined in the Canadian Nuclear Safety Commission, or CNSC's generic EIS guidelines, and also in CNSC Reg Doc 2.9.1, which covers environmental principles, assessments, and protection measures. One key note on the MPD environmental assessment is that we are completing this work under SIA 2012. In 2019 August, Canada's new Impact Assessment Act came into force. However, projects already in progress, like MPD, continue to follow SIA 2012. But what is an EA in more basic terms? An environmental assessment is a forward-looking planning process. It considers the environment as a whole. It reflects input from communities, including Indigenous communities. It considers alternatives for the project, and it considers the potential for cumulative effects. It assesses the significance of residual adverse effects and ensures the environment is protected. As I noted in my introduction, CNL submitted its draft EIS back in 2017 for review by federal and provincial regulatory agencies, as well as the public and Indigenous peoples. The MPD Closure Project has been busy developing more details for the decommissioning activities, as well as updating environmental studies and safety assessments to incorporate the feedback that's been received. In March of 2020, we submitted our initial revised draft EIS, along with more than 20 supporting technical documents. I'll provide a bit more detail about these later in the presentation. This package was submitted to the CNSC along with responses to the federal and provincial agency comments. The CNSC did a completeness review of this package and determined that additional improvements by CNL were still required. We have been working since the spring to address this feedback from the CNSC, focusing on improving our Indigenous engagement efforts. Next week, we will be submitting our second revision of the draft EIS to the CNSC. Pending a favorable completeness review, a 90-day technical review by the CNSC and other federal and provincial agencies will commence. This December 2020 revised draft EIS for the MPD Closure Project is going to be available on our MPD webpage early in 2021, in both French and in English. Now I'd like to highlight some of the key topic areas that were identified in the comments on our 2017 draft EIS from the public, Indigenous group, and regulatory agencies. First off, what we have heard from the public. From the formal comments that were submitted to the CNSC and through our engagement activities, we have learned that the public is interested in alternatives, grout and concrete degradation, design and engineering details, proximity to the Ottawa River, the radiological inventory, and International Atomic Energy Agency guidance on in situ decommissioning. Next, what have we heard from Indigenous communities and groups? Again, some Indigenous groups have submitted formal comments on our 2017 draft EIS, and we have also had feedback through our engagement activities. CNL has reached out to more than 12 Indigenous communities and has been actively engaging with 7 communities. Topics of interest for Indigenous communities are archaeology, biodiversity, Indigenous valued components, protection of the Ottawa River and land, Indigenous health, future land use and remediation, follow-up monitoring, and formal agreements and meaningful engagement with CNL. Finally, what have we heard from the federal and provincial regulatory agencies? Through the formal comment process for the EA, CNL has received comments from Environment and Climate Change Canada, the Province of Quebec, Health Canada, and the CNSC. Interest from the regulatory agencies is varied, but some topic areas are natural analogs, grout formulation, alternatives, radiological waste inventory, long-term safety, baseline characterization, valued components, Indigenous engagement, and follow-up monitoring. You'll note that between the 3 groups that we've identified as providing comments and feedback, there's definitely some overlap in areas of interest and topics of interest. So at this point, we've covered off what we've heard. And now I'd like to highlight some of the things that we've changed based on the 625 formal comments that the CNL has received on the 2017 draft EIS, along with other feedback we've received through our engagement activities. Before I jump in, I'd just like to note that in the header on these slides, you'll see a section number indicated. On this slide, it says section 4. For those who choose to take a closer look at our revised draft EIS once it's posted in the new year, that section number will help you zero in on the sections of the report where you can find these changes. First off, since 2017, we've improved our description of the project. We've provided the specific grout formula that will be used and more detail on how the grouting of the below-grade structure will be accomplished. We've identified a preferred on-site location for the batch mixing plant, and we've clarified that our ventilation stack will remain in place and explained how it will be isolated from the facility. We've developed a surveillance plan to cover the institutional control phase for the project, and we've also included an updated project schedule. A topic that was of interest for both the public and our regulatory agencies was our waste inventory and our understanding of that waste. We've done a lot of work to improve that understanding. So reference inventory is the limit of radiological or non-radiological contaminants which may be grouted within the MPD waste facility. We completed field characterization work in 2018 and 2019 to characterize the MPD building, the primary heat transport and moderator systems, and the reactor vault. We have also recalculated the activity of the MPD reactor components, updating the 2D neutron transportation code with a 3D solver, and looked closely at potential impurities and uncertainties in the material compositions. This update to the original modeling, which was done in 1988, is a significant improvement. PCB waste is another area of our waste inventory. All PCB containing lights ballasts will be removed prior to or as part of the decommissioning activities. The concentrations of PCBs in the solids at MPD has been tested and is below the regulatory limit of 50 milligrams per kilogram. If any PCBs above regulatory limits are discovered during our decommissioning, this waste would be deemed non-compliant and would be removed and dispositioned accordingly through CNL's hazardous waste process before we grout the facility. The last piece on understanding of the waste is lead. There's a significant quantity of lead associated with shielding, mainly in the fueling machine room, and the total quantity of lead present is estimated to be approximately 225 metric tons. One of the things that's improved since our last EIS revision is our understanding of the total volume of lead. Our previous estimate was approximately 435 metric tons. Next, changes to valued components, which are an area of interest for the public, Indigenous groups, and the regulatory agencies. Based on feedback we've received through Indigenous engagement, we've added additional valued components, species, to our assessment. We've included moose, fox, otter, mink, short-tailed weasel, berries, and mushrooms. Another improvement in the area of valued components is the valued components that are identified for the geological and hydrogeological environment. So since 2017, we've added soil quality, groundwater quality, and groundwater quality as individual VCs. We've also added a specific environmental component to look at Indigenous, socioeconomic, and health. Another key area of interest has been our baseline characterization data for the MPD site. Since the draft EIS was submitted, we have completed a phase 2 environmental site assessment and undertaken a targeted geoscientific characterization program. This has allowed us to update and improve our geosynthesis report, which is a key technical supporting document to the EIS. In the EIS proper, this additional characterization has allowed us to improve our description of the geological and hydrogeological environment. We've expanded and improved our description of site and regional geology. We've included information on mineralogical and petrological details for the site. We have new information on the local soil quality, including chemical contaminants. We have additional and updated information on the hydrogeological conditions and properties. We've added regional groundwater information, including local well information from the Ministry of the Environment. And we've been able to add data from our recent groundwater sampling. We've also undertaken baseline sampling work that will support our follow-up monitoring programs. This is important so that we have pre-project conditions at the locations and frequencies that are needed for monitoring during project execution and into the institutional control phase. In 2020, we completed sediment sampling, benthic invertebrate sampling, surveys of fish habitat, and established the baseline noise levels at the NPD site. In 2021, we will be doing additional work to sample surface water at key locations that are important for follow-up monitoring. We will also be sampling fish, and we will establish baseline dust conditions. As noted, we undertook some geoscientific characterization work that has allowed us to improve our geosynthesis work. This work allowed us to provide a better description of the intact rock and rock mass quality at the MPD site. And this improved geosynthesis report includes new information about neotectonics and paleoseismology. Those are very focused geological terms. So neotectonics is the study of motions and deformations of the Earth's crust that are in the current or recent geological time. And paleoseismology is the study of geologic sediments and rocks for signs of ancient earthquakes. Another improvement that has been made possible by our additional characterization efforts is an update to our groundwater model. Again, this is a key technical supporting document to our EIS. The groundwater model has benefited from the phase 2 environmental site assessment and the geoscientific characterization work. The model has been updated and expanded and has been calibrated with water levels measured at the NPD site. It also includes new figures that show water levels, water table elevations, and velocity and head contours. One of the areas of interest that has been important to the public, Indigenous groups, and our regulatory agencies has been incorporation of Indigenous interests. Since 2017, CNL has made the following improvements to our EIS. We've added a new environmental component that identifies Indigenous socioeconomic and health interests and potential effects. We've updated and enhanced our description of traditional land and resource use. We've included information on CNL's long-term relationship with Indigenous peoples, and we've added an Indigenous receptor to our post-closure safety assessment. Since the beginning of the project, we've been working to continuously improve our post-closure safety assessment that predicts how the disposal facility will perform many thousands of years out into the future, and also looks at how different potential future users of the site, or receptors, will interact with the environment around the MPD waste facility. As part of this 2020 revised submission, we have submitted the third iteration of our post-closure safety assessment. This iteration includes 2 new receptor groups, a self-sufficient Indigenous receptor and an offsite resident receptor. The offsite receptor is represented in purple on the right-hand side of this image. The Indigenous receptor is represented in red on the bottom left of the image. This image includes arrows to show how the different receptors may interact with the environment, from eating foods grown on the land, taking water from the river or a well, fishing, or spending time on the shoreline in contact with soil or sediment. The third iteration post-closure safety assessment continues to include a self-sufficient on-site resident receptor, which is shown in pink at the top of the image, with both a resident and farming activities occurring on top of the MPD waste facility. The post-closure safety assessment also still includes a recreational user of the area, which is shown in yellow. In all cases, for all receptors, the predicted dose from the MPD waste facility is only 0.0003 millisieverts per year, which is more than 800 times less than the project dose objective of 0.25 millisieverts per year, and 3,500 times less than the CNSC public dose limit of 1 millisievert. For reference, the dose that we are predicting is equivalent to the dose you would receive from an airport security scan or from eating a banana. Next, I'd like to highlight some of the improvements we've made to protect species at risk at the MPD site. First off, since 2017, we have been completing surveys of the MPD waste facility, and we have identified a small number of species at risk bats that are using a crawl space in the facility as a summer roost and winter hibernaculum. The revised EVIS describes the preliminary steps that we will take to exclude bats from the facility. As already mentioned, we are keeping the stack for chimney swift habitat, and our plans now include timing restrictions for any modifications to the stack to avoid, where possible, disturbing the swifts. We've also added some mitigation measures for effects on milk snakes related to road mortality. And finally, we have plans for regular surveys and replanting of milkweed to support the protection of the monarch butterfly. One key area of interest from the regulatory agencies is natural analogs, which are an example of how similar materials have performed over time to help us understand and predict how the MPD waste facility will perform. Components of the facility that can be compared to natural analogs are the grout, metal components, lead, the concrete cap, and the soil cover. Today, I'm just going to highlight how the natural analogs for a few of these match up with what we have modeled and predict for MPD. The first component of the MPD waste facility to look at is the grout. The grout incorporates blast furnace slag, which is a pozzolanic material similar to volcanic ash that's used in Roman cements. Roman cements have been shown to last for over 2,000 years with very little degradation. This validates the assumptions in our post-closure safety assessment and indicates that grout will survive and perform its function as a safety barrier. Next are the metal reactor components. These are primarily iron-based materials. Corrosion of iron-based materials has been studied in artifacts, native metal, and in meteorites. These materials have been shown to take thousands of years to corrode, which aligns with the corrosion rates we've used in our post-closure safety assessment. Finally, the soil cover. Here we can examine how ancient tombs with wooden coffins have stayed dry for up to 1,500 years when they are covered with a fine material such as clay. This is similar to our engineered barrier. We can also look at existing earthen mounds, such as those in Ireland and England that date to the 6th and 7th centuries. Also mounds in British Columbia that date to 1,500 years old. Again, these natural analogs demonstrate that what we are proposing for the MPD waste facility can remain intact and protected over the long timescales that are considered in our post-closure safety assessment. Alternative means or alternative options was another area that received a lot of interest in the formal comments and at our engagements. We recently shared information about our alternative options assessment during our June 2020 webinar, and that webinar is still available on our CNL YouTube channel. Key changes in the revised draft EIS were to bring additional content from the alternative means report into the EIS, and it's organized as noted above on the slide. We've also updated the description and visuals for the 4 alternatives. We've included a table to show the review of technical feasibility, and we've added detail on economic feasibility. And we've also revised the alternative means to include the availability of an offsite disposal within the institutional control period and include quantitative assessment of worker health, including radiological doses and workplace injuries for all options. Finally, another key topic of interest for both the regulatory agencies and the Indigenous groups is the follow-up monitoring for the MPD Closure Project. Since we submitted our original draft EIS in 2017, we have developed 3 draft follow-up monitoring plans that cover monitoring for both the decommissioning execution phase and the institutional control phase of the project. The 3 plans cover environmental monitoring, effluent monitoring, and groundwater monitoring. The map shown here has key environmental monitoring locations for the institutional control period, including surface water monitoring, the blue squares near the top of the image, and ambient radioactivity monitoring shown with green dots. The 3 plans that we have developed are based on the Canadian Standard Association, CSA standards, N288 4, 5, and 7, which correspond to environmental, effluent, and groundwater monitoring, respectively. We call our plans draft because we are looking for additional input, and we won't finalize them until we understand any requirements that may come from the EA decision. We held an initial workshop on our effluent monitoring plan in 2019 and plan to hold additional workshops in the first half of 2021 on the other 2 plans. So at this point, I'd just like to summarize the areas where key changes have been made within our revised draft EIS in response to the comments from public, Indigenous groups, and regulatory agencies. Items on this slide that are in bold are some of the things that we touched on today, but additional improvements have been made throughout the EIS. Before I move on to status and next steps for the MPD Closure Project, I'd like to highlight that the EIS is supported by more than a dozen technical supporting documents that are shown here in blue. Some examples are the Decommissioning Safety Assessment, the Post-Closure Safety Assessment, the Groundwater Model, our Geosynthesis Report, and an Ecological Risk Assessment. There are also a group of additional supplementary documents which cover things like our site characterization and follow-up monitoring plans, but also include supporting models that feed into our post-closure safety assessment. These documents form part of our EIS submission in 2017, and most of them have been updated since that initial submission. These documents will be submitted collectively together with our EIS as part of the package of our revised draft EIS submission next week. So now I'd like to recap where we're at with the NPD Closure Project and what the next steps are. So as I noted, the project is in the midst of a federal environmental assessment under the Canadian Environmental Assessment Act, or CEA 2012. We submitted our initial draft EIS to the CNSC in November of 2017. It's on the left side of this figure, shown in orange. Comments came in through 2018. And we've actually been holding on this red stage, this current stage, for quite some time. What's happened here is that CNL has made key changes to our EIS, which we've shared at previous webinars and highlighted today. We submitted a revised draft EIS along with new and updated technical supporting documents to the CNSC in March of this year. And in May, the CNSC requested further information to fully address comments from the federal and provincial agencies. In response to that, we're submitting a revision of the draft environmental impact statement next week. We're still holding in that red stage, and pending a favorable outcome to the CNSC's completeness review of our submission next week, they will commence a 90-day technical review of our revised EIS package. The outcome of that review is likely to be a set of additional technical information requests, typically much less than what we received on our original 2017, but still things that CNL needs to address before we're able to submit our final EIS. So the final EIS is highlighted in purple here on the timeline. Looking out, the 90-day review is expected to occur in the winter of 2021, approximately January to March. And then CNL will address any additional technical feedback over the spring and summer in advance of finalizing our EIS, perhaps in the fall. That's our purple circle, as I just noted. During this time, CNL will also be working to fully address public and Indigenous comments, incorporating necessary changes into our final EIS. If we follow the timeline along to the right, the commissioner hearing process, which is the blue circle, is anticipated to begin in 2022. And the timeline shows an EA and licensing decision occurring later in 2022, after which point CNL could begin the decommissioning work. Before I open the floor up for questions, I'd just like to take a moment to let you know that we're currently holding a virtual open house for the MPD Closure Project. You can find us at engagewithcnl.ca/NPD. This virtual open house went live on December the 6th and will stay open until December 20th. As part of this open house, we've set aside time for live chat, and the first opportunity for that is coming up tomorrow, Wednesday, December the 9th, from noon until 2. So please check out the virtual open house page for more information and other opportunities for live chat. Thanks very much for your time today. At this point, Juliette and I would be pleased to take any questions that you have.
Okay, thank you, Katie. So we do have a couple questions, and I believe one has already been answered. But we have another question, and that is about the waste inventory. And it is, will any more radioactive materials still in NPD be removed as unsuitable to be left grouted in situ? So Katie, I'll turn that over to you.
Yeah, no problem. Thank you for that question. So the answer to that is no. The plan is to leave all remaining material, radioactive or otherwise, in place inside the MPD facility and grout it into a monolith.
Okay, and I will go over the question that was already answered, but it was just to clarify that this is the revised draft environmental impact statement that we will be submitting next week. So another question, when did the NPD Closure Project begin? What was the original budget amount? How much has been spent on the project to date? What is the current estimate for total project cost from start to finish? So a couple of questions in there, but I'll hand that over to you too, Katie.
Okay, again, great question. And I won't be able to share all the details about budget, but the NPD Closure Project was announced back in 2015. So that's the point when it originally began. Our project description was posted to the CIA website in 2016 with an opportunity for comments. And then, as I noted on the timeline just a couple slides ago, the initial draft environmental impact statement went up in 2017, and there was a formal public comment period in 2018. I think my description of what's up next should answer your question about how much longer do we have on the project. The only details I'll add beyond what was shown on that timeline are that the decommissioning execution is expected to take approximately 2 years. So after we have an EA decision in 2022, that's the likely date, there will be 2 years of decommissioning execution, and then we enter a period of institutional control for at least 100 years, where we would do follow-up monitoring to make sure that the facility is performing as expected. At the end of the institutional control period, which is a time period where the site continues to be licensed by the CNSC, there would be a decision about the next step for the waste disposal facility. And I'm going to have to just defer the response on budget. I will have to follow up with you after the fact on that. I don't have the numbers in front of me.
Yes, and we will send out a follow-up email too, and we can provide a bit more clarity on that. So another question, how much additional characterization of materials will be done during the physical decommissioning process?
Thanks for that question. The plan is not to do a whole lot more additional characterization. We've focused a lot of time through 2017, 2018, 2019 to sample different aspects of the reactor systems, the building, to characterize the land around the MPD waste facility. And so the efforts really will be to demolish and fill the remaining void space with grout.
Okay, thanks, Katie. So this might be one that Juliet can also assist with. And this is, did any of the additional geological and groundwater analysis change any of the predicted effects for bounding scenarios? Do you want to start, Katie?
Yep, no problem. I can jump in on that. So the post-closure safety assessment considers our conceptual site model for MPD, which is built based on the geological characterization and groundwater characterization. But the other thing the post-closure safety assessment does is investigate several sensitivity cases where we change some of the hydraulic properties through the facility, where we change the degradation of the grout. There's a series of different sensitivity cases we run to understand how things will happen if they don't go as predicted. Things that we have less certainty on, we use the sensitivity cases to help us understand what will happen in the end. So one of the things that comes out depending on the new groundwater information is that we were actually able to calibrate our groundwater model. So with the groundwater elevations that we measure at MPD, we've been able to have our model predict those concentrations. So that gives us confidence that the way that the model is predicting the groundwater is moving, going out into the future, is accurate. I just want to make sure I answered the end of that question. So the short answer is that the new geological and groundwater information has confirmed that our predicted effects and bounding scenarios are still within the, well within the dose objective for the project.
Okay, thanks, Katie. So we just have one more question up here right now, and it is, does your post-closure monitoring plan include any predictive monitoring, for example, online monitoring that would indicate something is changing before sampling and analysis? So Juliet, did you want to take this one?
Sure, I can take this one. My name is Juliet Louise. I'm the environmental analyst for the NPD Closure Project. Our post-closure monitoring plans, especially for the grouted facility, relies importantly, on groundwater monitoring. We'll have wells located up gradient of the grouted facility, as well as between the facility and the river. So that's the monitoring that will indicate and confirm the facility performance. I hope that answers your question.
Okay, thanks, Juliet. So at this point, there are no questions. Sorry, Katie, did you?
Yeah, I'll just jump in really quickly. So I think the last piece of the recent question was, would there be any monitoring that's done to predict things before we sample and analyze? And really the short answer to that is no. There's monitoring of the groundwater, as Juliet mentioned, very close to the down gradient edge of the facility. And so that's the first place we would see something, and that would give us the heads up before anything made it to the surface water or the rest of the environment.
Thanks, Katie. Okay, so I just put a link to the feedback survey in the chat, and we will also send that out by email after our NSDF webinar, which begins at 1 p.m. this afternoon. So if you're interested in attending the NSDF webinar, just head to cnl.ca/webinar, and there'll be a Zoom link there for the NSDF webinar at 1. So at this point, there are no questions. So I'd like to thank everybody for coming, and hope you can make it out to the virtual open house in the next few weeks. Any last words from Katie or Juliet?
Nothing further. Thanks for closing us off, Margot. And just a reminder, I don't think the link's there, but the virtual open house is engagewithcnl.ca/NPD. Thanks, everyone.
I just put it there. Perfect. Thanks, everyone. Oh, sorry, I do have one more question that just came in. This project results in a radioactive waste disposal facility. The meaning of disposal assumes the site will eventually be abandoned. As such, the residual radioactivity should meet abandonment criteria. When will this be achieved? So Katie, can you speak a bit to this?
Yeah, great question. So I don't have off the top of my head the time when the radioactivity would meet the criteria that you're identifying for abandonment. But the institutional control phase and the continued licensing by the CNSC is our mechanism that we don't abandon this facility until we know that it's in a safe condition to do so. So at least 100 years of institutional control, that's our institutional control phase. And at that point, we would revisit, we would revisit with the CNSC the appropriate license for the site.
Okay, thanks, Katie. And through the survey and through our email address, there's always opportunity to ask more questions. And we will also have further follow-up in an email. Sorry, there's one more question. Does the safety assessment provide that estimate on the question we just answered, the residual radioactivity meeting abandonment criteria? I believe that's the question, if the post-closure safety assessment would provide an estimate on that.
Yeah, so great question, great follow-up. The post-closure safety assessment predicts the concentrations that reach the environment based on what's left as inventory within the grouted facility and decay that happens over time. So again, I don't have that timeline off the top of my head right now, but I'd be happy to follow up with you after the presentation.
Yeah, so that's something we can provide a bit more detail on in our follow-up emails. Okay, thanks again, everybody. And at this point, I am going to end the meeting. Thank you.